Okay, it's 1 o'clock here in Vancouver. Welcome to the spring meeting. Thank you all for being here. I know it's Friday. I know it's been a long week. Thank you for still hanging out with us. Bruno is over there on the video.
Hi.
Joe may not be able to make it today. So please, if you're in the room, go ahead and scan the QR code that is somewhere now. Please make sure to scan it only once so that we don't get this huge room again next time. It feels like we're not the big happy family or the small happy family that we are here in spring. And once again, if you want to see the slides, you of course can log into the Mediaco client, or maybe you want to move over to the left of the room where the slides are. Okay, let's start. Bruno, go ahead with the next slide. So I know that it is Friday, and sometimes we kind of gloss over the note well. This is just a reminder of the policies that you, of course, already agreed to when you register for the IETF around conduct, around intellectual property, and around the harassment policies. Please make sure that you're familiar with the policies that are linked from there, not just with this page, but with the policies when you are deciding to make contributions to the IETF. Next slide. Next slide is just to focus a little bit more on some of the important things about the code of conduct and the expectations that we have to be all friendly and to collaborate in an open way in the IETF. Next slide. Some meeting tips, if you need them at this point in the week. Next slide. The minutes are, of course, a reflection of what we do here in the working group. Shuping, our secretary, is online and she's taking minutes. Please follow the link. You can also click on the Mediaco client and get to the same headstock page so that you can collaborate on the minutes. Check, especially if you say something, if you have comments, that the comments are reflected properly, that your name is spelled right, all those things. So please go online and help us all with the minutes. Next slide. So we've had some document activity since last time. In here we're showing 3 drafts that have moved. The first one on the Path MTU for the SR policy was adopted by the working group. I know there was already a working group document, the draft IETF spring document posted a couple of days ago. That is not reflected here. We were waiting for this when we did the slides at the beginning of the week. There is an ongoing adoption call for the SRV6 and PLS interworking draft that has gotten some traffic on the list, and this is going to be open until August 1st. You'll notice that we did that on purpose, not ending the call during the meeting, because we know that everyone's busy during the meeting. So on purpose, we extended that a little bit longer than the normal 2 weeks. And in other news that I'm sure all of you know, we have submitted the SRH compression draft to the ASG for publication. Next slide. This is the list of the approved working group documents. They're listed there in order of when they were last updated. So there are a couple at the bottom that are expired, right, because they were updated last. Please, if you're the author of those drafts, please keep them alive so that we know there's still interest in them moving along the working group. You also notice that the working group last call indication in the last column there of them being in the working group last call queue, not all the documents are, right? And it's not depending on where, if they're older or newer or anything like that. We have been mostly working under the mode where we wait for the authors to ask for working group last call. In a couple of slides, we're going to start reviewing a proposal for an updated charter. And with that update, we're going to change some of the ways of how we do the management of the working group. So we're going to pay a little bit more attention and ask for your collaboration, because we're a working group, right? We're not just chairs. All of us have to be in this together to make sure that the documents that get to the stage of working group last call are ready for working group last call, and not that we start working on them when we put them in the queue. Next slide. This is the adoption queue. Drew, did you have a question?
Dhruv, can we go to previous slide? Just on list of the documents. Only wanted to highlight the working group. There are work, especially which use SR policy Yank, and currently the document, though it got an update this time, there are still pending issues that we have told the authors for a while. Right now, the document is also not compiling, so it's creating errors for all the other models which are augmenting it. So just a request to the authors to please keep this in track and update it. Thank you.
Thanks, Ruth. Yeah, both of the Yang drafts in there had actually been expired a few months ago. So it's good that we have renewed them, because there's some dependencies on them. Next slide. So this is the list of the adoption queue. This is not in order. You can go check the wiki, but just so that you know that this is what the adoption queue looks like. And similar to what I said about working group last calls, we're going to want to have a tighter, I don't want to say control, but have a tighter hold on the drafts that are being adopted. Because again, we want the working group to participate. And we need to do this as a working group. Next slide. Okay, we're going to now talk about the spring rechartering. I'm actually going to stand up there because I can't sit and talk at the same time. Okay. Thanks. Is this on? Yeah? Okay. So the spring charter was last revised 6 years ago. That's a long time. And if you look at the milestones that we've been revising in the last few weeks, many of them are already taken over by events, right? We calculated that we'll be done with the work about 3 years ago. But we still have some milestones that we haven't finished. And so it's time to take a look at this. The other reason we're taking a look at the charter is because the SRV6 Ops working group was chartered. They met for the first time this week. I hope that all of you were there. And we had to make some changes to our charter to make sure that it didn't say that we were the home of SRV6 operations. We sent the charter to the list. I'm very disappointed that no one said anything. I did a couple of comments unicast, but no one said anything. So what I'm assuming is that you're all happy with the charter. And as I said before, we need this to be a working group, right? If there's no working group because no one agrees to the charter, then maybe we need no room next time. And we can just go home and not do this anymore. For those of you who came in late, I don't mean to shame you or anything, but it might be good if you sit on this side where you can see the slides. Just, Bruno's on the other side, so that's also a good view. So you can stay there if you want to. Okay, please take a look at the charter on the list if you have comments. We're going to spend some time here today to do this. Bruno, next slide. So these first two paragraphs of the charter are basically the same as the ones before. The only thing that changed in the first paragraph is what is highlighted and underlined there, that it specifically says that this is a forum for discussion of SR and PLS network operations. Before, we also highlighted that we did just SR operations, but now that SRV6 ops is somewhere else, then we're just kind of making sure that that is what it says. The second paragraph talks about the fact that we need or want to avoid modifications to existing data planes, and that any work on data plane or control plane is going to happen on the working groups that own that, right? When we did the SRH, it was done in 6-man. Even though it was for Spring, it was done there. just like all the IGP extensions are done in LSR, BGP, etc. Next slide. If you have any comments or questions as we go through this, please get up and talk about this. This next paragraph is a summary in general of what the working group does. Procedures that allow a node to steer packets through an SR policy. The text is very similar from before. I put the diff there. We just did some editorial changes. No big deal, I think. But yeah, just take a look. Kevin.
Ketan Talaulikar, Cisco. Since you made editorial changes, what is a Spring node? Because that's not something that's defined. Do we mean segment routing node? Perhaps.
Yeah, I see what you mean. It says, however, Spring nodes. Yes, so we'll write that down and I'll look at it. Yes, we need to be clear there. Okay, next slide.
Antoine is in the queue.
Yeah, Antoine. Oh, you might want to go back around.
Yeah, it's on the first slide.
Name.
Antoine Franco, Huawei. On the Spring Proposed Charter first slide, you mentioned that SR and PLS operations are still in the scope of the group. Wouldn't it be simple to delegate this to the SRv6 ops group and like SR ops groups, so they also tackle the SR and PLS options, and there is an ops group for anything, and the core net protocol specification that is done in Spring?
So I'm going to say that two things. One is that boat already sailed because we already chartered SRv6 ops. And the other one is that is, of course, way above my pay grade. And I'm sure Jim is online, our AD, and he's going to take notes and think about that in the ISG. Thanks. Okay, next slide. Okay, so here we did a little bit of scoping work. It says segment routing works within a trusted domain that requires strict enforcement at the borders. Trusted domain is defined in 8402, but it also says that some deployments involve multiple domains, and that documents that deal with multiple SR domains will need to have risk analysis and use mechanisms to make sure that the segment list is provided by an authorized entity and that it has not been modified in transit. That is very similar to what the text that was there before. Again, some editorial changes. The second paragraph, if you can see the diff over there, we eliminated completely. All that second paragraph says is, as is customary in the routing area, and not just in the routing area, but in the whole IETF, we care about security, and we're going to put security considerations in every draft. We don't have to put that in the charter because that is a mandate of the IETF, right? Every draft has to have security. So it's kind of redundant to put it in there. So we decided to take that out because it didn't really add anything to the scoping or to the actual operation of the working group. Comments? Okay, good. Next slide. The bottom part of this next slide, which is the last part of the charter, is who we're going to coordinate with, right? I think SFC was on the list before. That working group is closed, so we took it out. We added SRv6 ops and cleaned a little bit. I didn't put the diffs into here, but we cleaned a little bit just so that we were consistent in what we were saying. You know, LSR on, IDR on, you know, those types of things. The top part, the one that's highlighted and underlined, that is, I think, the most important change to the charter. In the current charter, we have a list of work items. As I mentioned, when we did this charter 6 years ago, we should have finished those work items about 3 years ago, right? But we didn't. So what we want to do now is, as it says there, we're going to manage the working group and the specific work items based on working group input and consultation with the AD. What that means is that we are not going to list specific items on the charter, but we're going to manage the milestones more strictly. I showed the working group documents before and the adoption queue before. What that means is that we're going to manage that process a little bit more strictly now. We're going to put milestones in the data tracker when documents become working group documents, not when people come up with ideas, right? Because at that point, we know the working group is committed to doing something and we can do something in there. We will figure out what that process looks like. And of course, consult with the working group or let you know what we're going to do. And we'll go from there. So what that really means is what I mentioned before. We need more working group interaction to make sure that what we're working on is what the working group is committed to do and deliver. Tom, or Drew, I think you're first. Sorry.
I think it's just a slide mistake, but PC is missing. It was there before, but
What is missing?
Ici,
oh, best
Oh,
open
yeah, sorry.
Acha, you didn't put it in the second line. Oh, got it. It's
Yeah.
fine. And second question that I had was with respect to the milestone. So when we are saying that according to the milestones agreed, so any thoughts on how would we come into an agreement on this? Because I'm worried that every author would say mine is the most important one. So what's the thought on how do we agree on the order of importance?
Right. So, well, two things. One, as I just said, I think what we're going to want to do is define a milestone when we adopt something, right? So that means that the working group agrees that this is something we want to do. What we haven't figured out yet, and we want to think about this a little bit, is how we're going to manage the milestones. If any of you were at the All Dispatch working group on Monday, there was a proposal there about the management of the milestones that we actually can do today. But basically, normally you put dates to it. And of course, sometimes we look really bad because we should have completed the work 3 years ago and we haven't done it. Or even worse, we didn't update the milestones for the last 3 or 4 years with work that we actually did finish. So that's one option. Another option is that we don't need to necessarily list dates, but we can list priorities. Now, those don't have to be priorities, and in draft A is the absolute most priority of the working group. It may be, and this is something we need to agree on as a working group, it may be a queue type list, right? This is the first one. We're going to try and work on that one first, and then we go to the second one. And if there's any change in the ordering, then we need to agree as a working group to do that. Which agreement as a working group to me means that we are committed to reviewing, that we're committed to making comments, that we're committed to participating. Not that we're just saying, yes, I like that draft, but that we're actually going to work on that. Tom.
Hello, Tom Hill from BT. If you may go back a slide, sorry, it took me a little while to grok the changes. Proposed Charter 3, yeah, that one, yeah. There's a lot of change in here. There's obviously a lot of text that's been taken out. I think in the kind of gutting of this, I can see where there is modernization to this, which is completely appropriate, but also I'm kind of concerned that we've removed the word security entirely. And I think that that's, for posterity's sake, quite a mistake, especially when we have a draft going through the working group process of called security considerations. I think that's really important that we make sure that that word is in there. It is important. Furthermore, the word untrusted is not in there. And I think it's a mistake to take that out as well. So as much as I'm relatively happy with the slight expanding of scope and slight changes in here, I think you may have cut this down a little bit too far.
Okay, please, if you have text in mind. So as I said, the second paragraph was one to talk about security, and we took it out because that should be table stakes for everything. If you have wording that we should add, we're happy to take a look at that. One thing that I want to make sure is that we use terms that are defined. So there is a definition of a trusted domain. I'm assuming that the inverse of that is an untrusted domain, or an untrusted node, or whatever you meant by untrusted.
I don't think it hurts us to, I think security is quite well defined, but I don't think it hurts us to actually make specific reference to untrusted. And the concern that I have is that sometimes when we find ourselves with contentious work, someone points at very literal text in the charter and says, well, it's not there, so we're not doing it.
Right. So all I'm saying, I'm not disagreeing with you. All I'm saying is that if we're going to use the word untrusted, we need to make sure that we know what it means, so that in the future, the same thing doesn't happen where I point to the charter and say, well, but it says untrusted according to my definition, and it's not your definition.
We have a history here of arguing over very strange, ambiguous language, and
Right.
I don't want to invite more of that in the future. So even though untrusted is well defined already as being the opposite of trusted, I think it's important to explicitly mention it.
Okay.
In
So,
text. Yes, I will make a point to try and look at
perfect.
proposing some text.
Perfect. Along with Tom, please, everyone else, go look at the charter on the email, because we want confirmation there, of course. Next slide.
Rakesh is waiting.
On the next slide, where there is list of working groups, I know it's not an exhaustive list of working groups that we work with, but we have been working with IPPM working group for the lot of PM stuff. So I wonder if we should include the IPPM working group here.
Sure, please reply to the list. Yeah. So, personally, we can include whatever we want. There's no binding contract between working groups that we need to work together. So yes, we can include everything. Please, if you think there's something missing, we can add it to the list. Fix that thing with the PCE that needs to go to the next line, and then we'll make at least Drew happy with that. Okay, anyone else? Okay, so Tom is going to propose some text. We, the chairs, are going to talk about how that mechanism of managing the milestones is going to work and let you know what we're thinking. And everyone has the homework to go to the list. Don't do that now because we have a very exciting number of presentations, but everyone has the homework to go to the list and comment on the charter. Yes? Can I at least get someone to nod and say yes? Okay, thank you. Okay, so this is the agenda that we have for today. As always, we have a lot of presentations. We're going to start with the security considerations draft. Luis is going to talk about this.
Hello, everyone. This is Luis. I will present operational security considerations on behalf of my co-authors and also on behalf of Nick that couldn't make it here. Next, please. So just a recap where we are, how we are advancing the draft, how we are evolving the draft. So in version 02, that is the latest available, we have added the reference to the RFCs that are we are covering, let's say, in this security assessment. We also have moved some content to two specific sections on impact and attacks. Before of that was somehow diluted the content in the document, so we have established these new sections for making the content much more clear. Also, we have added a description on the hash message authentication code, which is for the securitization of the SRH. And for sure, editorial fixing, that this is a continuous effort for making the document better from the perspective of the readers. Next, please. So for the subsequent version, even though we already have created the scope is just the list of RFCs I commented before. So the idea would be to be a little bit more verbose on the description of the scope. So that could be more evident and more clear what is the scope of the document, what are basically the context of the document and the perimeter of the document. Then also we are reworking on the threat model section. There are some discussions between the the co-authors from the design team what should be the approach. The HMA is something that we already have covered, and also we will be working on adjusting the middle box filtering issue section to reflect the comments received so far. Next, please. So we are yet working on the 3D model, as mentioned, and this is a discussion, so we need to clarify even better among us what will be the proper approach. We are looking for more input to the group. We will see later on at the end of the deck that we have the public repo there, so it would be perfect if you can jump on that and propose pull requests and whatever other comment that you consider relevant for it. And regarding adoption, we saw that there is in the potential adoption queue. So yeah, we are working for that, and we would like to that the document become adopted as soon as stable. Next, please. Open questions. There was some traffic on the mailing list about the microtab segment topic. So this is something that maybe could be of interest to be covered. So this is an open question for the working group if we need to do so. And also what else? So what other topic the working group considers relevant to be covered by the document, so in such a way that we can focus on that topic. So please, state your interest in the mailing list, and so on, we can go through that. So Alvaro, do you have a question?
Yeah, thanks. I added myself to the queue. Two reasons. One is, if you guys remember this working group or this document, the reason we're doing it is because we got a specific request from the IESG to do it. And the request specifically was to look at security considerations in segment routing as it was defined, whereas it is defined, right? So what that means is in the existing RFCs. So I would say that addressing security in upcoming things is out of scope for this document. The other thing that I want to say is that we do plan to soon call for adoption of this document, right? This we, I think, all agree security is important, and because it's a commitment to the IESG, we want to move this as fast as we can. Thanks.
Thank you.
Hey, me again, sorry. So there's a couple of, I should probably say actually, for the record, Tom Hill, BT, I'm quite impressed with the rewrite. So in Brisbane, I thought this was a little bit lacking, but actually I'm quite impressed with the rewrite. There's a lot of extra work that's gone into this, so thank you very much for doing that, that's great. Section 7.1.2 has a typo in it. Lua addresses, you might have seen that already. The other thing it doesn't mention is draft IETF 6-man SIDS. Suresh's draft on obtaining a prefix for SIDS, reserved one. I think it would be well worth making a mention of that, because I think that's important, because, I mean, leading from that point onwards into Section 8, either Section 8.1 or maybe an unwritten as yet Section 8.3 that doesn't quite exist. It doesn't really mention anything about the fact that your source SIDs, that the SID prefix that you're using is completely unstandardized, right? There's kind of one suggestion that says from one ISP, well, we'll just use GUA. Another one says, we'll just use ULA. That's a real problem that exists within a lot of the scenarios that you've defined here, particularly of leaking things out of the trusted domain. So I think it'd be well worth expanding either 8.1 or writing 8.3 to cover that very specific problem. And it does refer obviously back to draft IETF 6-man SIDS. And I think you've mentioned it elsewhere in the document, where you've mentioned that some of the SID compression mechanisms do not use an SRH at all. And I think Section 8 should probably cover that in more detail as well. The problem that exists there with not being able to distinguish these things from an IPv6 packet. So broadly, this is great work, but I think Section 8 needs bolstering quite substantially. Anyway, and
noted. Thank you for the feedback.
I will do my best to try and submit some text as well at some point, I promise.
Would be wonderful. So
I'll try. Thanks.
Thank you, Tom. Thank you.
Hello, Nangang from Huawei Technology. I had a quick look at the draft, and by default, SRv6 is deployed within a limited domain or trusted domain. Yeah, and it's also mentioned in the trust model section, right? And I wonder, trusted domain is a sample or a solution? I mean, we deploy SRv6 in trusted domain is a solution to solve the SRU security problems, or is just a assumption of our analysis scenarios.
I couldn't get the latest point. So you were mentioning if the trusted domain is the scenario for being deployed, yes, but what else do you mention? I couldn't get it. Sorry.
Okay, I can give a comment here. I mean, suppose deploying SRv6 in trusted domain is a solution. Maybe we can move the descriptions about this trusted domain deployment request to the mitigation section, right? Or suppose it's an assumption, it's our target analysis case. Maybe some of the attacks or threats are not in the scope of the analysis. Yeah, that's my comment.
Noted. Thanks for the comment. We will analyze that. Yeah, thank you. So, yeah, coming back to the
we have a couple more people in the queue. Jim.
Oh, sorry.
Yeah, real quick one. And actually, I can see Dhruv actually mentioned it in the chat now, but it might be useful, or just a suggestion that you might want to run this past SRv6 ops as well. Just send them, a pointer to the link. I suspect everybody that attends that also attends Spring, but it wouldn't hurt. You might get more input.
Yeah, we'll also make a point of copying SRv6 ops on adoption when we get there.
Thank you. Thanks, Jim, and Dhruv as well for that. So just to Tom's point, right? Yes, like we are very close to having an RFC number for this, but the block is already ready. So you can just talk about the block that's been allocated for it. And I have the number in my head. It's not published yet, but I think we are ready to add the stuff to the prefix. And to Nan's point, the idea is, right, like if you're in a like trusted domain, some of these don't apply, but this is really a checklist of things you need to check for. So I don't think there's anything specific to say like this doesn't apply for trusted domains. It's just for somebody to evaluate and say whether it applies or not, right? Like maybe that could be a separate document that somebody writes, like probably the operator side and say, hey, we looked at these things, and in our kind of deployments, these things don't matter to us because like, we are in a single administrative domain. I think that could be a separate thing, but I really don't want to call out each thing separately here, whether it's applicable to trusted or not. Thank you.
Thank you. Thank you for the comment. So yeah, the final slide, I think, is this one. So we are here showing where is the repo. So yeah, feel free to jump in and propose whatever thing that you would like to be considered. And I think that's all.
Yeah, it's just a quick reminder. It's great if you want to go on the GitHub and do comments there. Please remember that the mailing list is the authoritative source of anything. So if you're going to discuss anything, please find a way of discussing it on the list as well.
Thank you.
Thank you, Luis. Okay. So now we're going to go move forward to Ran. Yes.
Hello, everyone. I'm Zan from ZTE. Today, I will present the validity of SR policy candidate path on behalf of all the co-authors. Next, please. Yes, this is the introduction. SR policy architecture are specified in FCC 9256. As a policy comprises one or more candidate paths, of which at a given time, one and only one may be active. Each CP in turn may have one or more seed lists, of which one or more may be active. When multiple seed lists are active, then traffic is load balanced over them. However, a CP is valid when at least one seed list is active. This candidate path validity criteria can't meet the needs of some scenarios. This document defines the new validity control parameters based on FC 9256. For the segment list invalidation rules, refer to FC 9256 and draft new spring as a policy flexible path selections. This document doesn't change the segment list invalidation rules. Next, please. So this is a motivation. The candidate path validity criteria defined in FC 9256 can't meet the needs of the following scenarios. The ISA policy has two candidate paths, CP1 and CP2. CP1 is the active candidate path, and the segment list SL1 and SL2 of CP1 are installed as forwarding instantiation of as a policy POL1. The CP1 carries a total of 200 MB of traffic. Within the POL1, the flow-based hashing overweight each SL with a ratio 50%. That is, each SL carry 100 MB of traffic. And this time, if one of the segment list is invalid, the remaining segment list can't carry 200 MB of traffic. However, based on FC 9256, the CP1 is still active. Next, please. This is for extensions. We define the following validity parameters and the candidate paths to control the validity judgment of candidate paths. The first parameters is valid SL count. 8-bit value, which indicates the minimum number of valid segment lists and the active candidate paths. 0 indicates no requirement for SL quality. 0xFF indicates that the candidate path is considered valid only if all the segment lists are valid. The second parameters is valid SL weight. 32-bit value, which indicates the minimum value of sum of weights of the valid segment list and the active candidate path. 0 indicates no requirement for weight. 0xFFFFF indicates that the candidate path is considered valid only if all the segment lists are valid. Candidate path is considered valid only if both validity countermeasures are satisfied. Next, please. There are some more updates since last presentations. Based on Joe's comments, we clarified the segment list invalidation rules refer to FC 9256 and draft new spring as a policy flexible path selections. Based on Samuel's comments, we changed valid SL quantity to valid SL count. Sorry, there was a typo here, quality, yeah, which is closer to common terms. And we add Yishong, Cotton, Samuel, and Rafa as co-authors. Next, please. Comments welcome. And we think this solution is simple, useful, and stable. So we would like to call for adoption. Thank you.
Any comments or questions? Before we consider the document for adoption, we need you to cut the number of authors on the front page. Currently, I counted 7. We need 5 or less. Comments, questions, suggestions, volunteers to review?
Maybe we have discussed most of the list. So we have solved all the questions in this version. Maybe it is stable.
Okay, so I guess we're going to move forward. Thanks.
Thank you.
We now have Yuan or Yi on the SR6 interlayer network programming.
Thank you, Mr. Chairman. I will present for this contribution. I'm Liu Yanhan from China Mobile, and the authors, the current authors are from China Mobile, Huawei, and ZTE. Next slide, please. Next, please. Oh, thank you. First, we introduce the background for this draft. The operators usually have a multi-layered network, including the layer 3, and also include the optical network and maybe include the layer 2 networks. The cross-layered network planning and optimization is expanded for better efficiency and resiliency. SRv6 enabled network programming by encoding network instructions in IPv6 packet handler, but currently it only the network instructions related to IP layer are defined. The SRv6 network programming concept can be further extended for interlayer network integration. For example, in the layer 2 and the optical layer in the networks. So this document describes the typical use cases of interlayer network integration and proposed SR6-based mechanisms for interlayer network programming. Next, please. We think the use cases of interlayer network programming at least include the first use case is the IP and optical network integration. Redundant optical passes currently may not be fully used by IP layer. The optical passes may exist between non-adjacent IP nodes that's not visible in the layer 3 topology. So we can use the SRv6 extension for the IP and optical integration. The next use case is IP and MTN, the Metro Transport Network interlayer integration. The MTN technology and architecture has been defined in ITOT recommendations. MTN nodes can support both per-hop IP forwarding and MTNP cross connect. The MTN paths can be sent up between two remote MTN nodes. So traffic can be carried use IP paths, MTN paths, or the combination of IP and MTN path segment. So we can use the SRv6 extension to integrate the IP and MTN networks. Next, please. In this draft version, we give two new SRv6 endpoint behaviors. The first is endpoint XU, a variant of end.x. The next is end.docs BXC, a variant of SRv things binding things. We think the functionality in the data plane for the two new SRv6 endpoint behaviors are similar. Both of the behaviors can enable the programming of interlayer T parses. Each option has different implementations on the management plane and control plane functions. So operators may choose either of them that best suits their use cases and networks. The management and control plane extensions will be specified in separate documents. They are not included in this draft. Next, please.
We have a question. We have someone on the queue, Sasha. You'll wait? Okay, he's going to wait till the end. Go ahead.
Oh, thank you. The option one is SRv6 and .xu behavior. It's a variant of the .x behavior. The setting instance of this behavior is associated with the underlay interface, which connects to the remote node where underlay links or connections. So the end processing is replaced to send the packet through one of the underlay links associated with the underlay interface. Next, please. The option 2 is SRv6 and .bxc behavior. This behavior is a variant of the SRv6 and behavior. The setting instance of this behavior is associated with the underlay tunnel, for example, the layer 1 or layer 2 tunnel. The end processing is replaced to forward the packet to the new destination where underlay tunnel. Optionally, this behavior may require to carry additional information, for example, by the argument for its processing. The high part of argument may be used to encode the channel type, and the lower part may be used to carry the channel ID. And the underlay tunnel is uniquely identified by the tunnel type and the channel ID. Next, please. This slide will list the updates since last presentation. The most important update is in this version, we merged the .bxc behavior divided in another draft, and we merged the two options in this draft. And next, we elaborate the reason of introduce new behavior rather than use the existing .x behavior. Since the underlay connections can be unidirection, which doesn't meet the bidirection check for the functional layer 3, and operators may want these underlay connections being invisible in layer 3 topology, so they can only be used by a controller for cross-layer traffic engineering. And the endpoints of the underlay connections may reside in different areas or different domains, which makes the establishment of layer 3 end-to-end tunnel difficult. And we also clarified the possible mechanism of obtain layer 2 information required for packet encapsulation, for example, to use a static only cache. Next, please. So we think that this document has addressed all the received comments, and since the multi-layer of networks is common in the real networks, operators have interest to deploy it in SRv6 next for interlayer integration, and we also hope to apply for WZ adoption for this draft. Thank you.
Thank you. We have some questions in the queue. Sasha.
Sasha Weinstein, Ribbon. I want to ask a question, first of all. Suppose, as the draft says, that I have an underlay path between two IP nodes. Suppose that the first of this, one of these IP nodes, the upstream IP node, has advertised one of these new, an SID with one of these behaviors received a packet in which this SID is the top SID, strips it because it's a variation of index, and sends it via the underlay. My question is, how should the node at the remote end of this underlay link know what to do with an IPv6 packet it has received? Because underlay links are not, how should it know indeed that it deals with an IPv6 packet if it receives it directly from the underlay? It seems that this is, if, from my point of view, this means that in order to be able to do that, the remote nodes should identify, associate some IPv6 capable interface with this underlay. And if you really do that, then you may have if both endpoints are IPv6 capable interfaces, then I think you don't need any special behaviors. You need the normal and X behavior, and that's it.
Thank you for the comments. Maybe we can go to the use case slide in, I think the slide 2 or slide 3. We have two, yes, this slide. We can see that if we have the optical network and the metro transport network, for the underlay network, the nodes also have the processing ability of the layer 3 in its client side. So it, for example, for the MT node, it can receive the end behavior, the seed from its ingress interface. Then it can use this seed to indicate which emptying path it can slide for this end-to-end seed. So it can slide the underlay path automatically by the indication of the seed list. So we think it bring many advantages for the end-to-end programming, and the underlay paths can be selected and visible in the control plane. Thank you.
I'm not sure I have captured all you have said, but again, what I say is, my point is that
maybe we describe this on the mailing list a little bit better. Yes.
Sure.
Thank you. Or we can discuss in the mail list first.
Presented my point. Let's take it to the list.
Kevin.
Ketan Talaulikar, Cisco. If you could go to slide number 7, and this is also what I think Sasha was saying. The statement here that n.x is only for L3 is not actually accurate as listed on this slide. n.x, that same section of RFC 8986 says that we can allocate it for L2 bundle members, which is kind of similar to, we can think of it like sub-channels under L3 interface. So that's an L2 bundle member. This is optical sub-channel. There is a lot of similarity. And I guess I'm thinking this is probably the point that Sasha was making as well. So in that case, I agree with him. The second point is I'm glad to see the two drafts merging, and now we have two variants. One is the n.xu and the other is the binding seed variant. It would be good if, and the draft is not very clear on when we need the binding seed and when we need the n.x seed. So feedback to the authors, if you could consider coming up with one of them, not two, which both of them could take arguments, and that may be, it's just a suggestion. Thank you.
Thanks, Kevin. G.
Yeah, just a quick response to Sasha and Ketan's comments. I think basically in the definition of this obviously 8986, the end.x is for the layer 3 adjacency. I think that is the definition there. And another thing is, as mentioned here, if we want to use the end.x for non-IP layer and unidirectional links, that the behavior will be different from for layer 3, because for layer 3 you need a bidirectional chat for a link to be visible and can be used for packet forwarding, right? But for this, we want to do some traffic engineering for specific kind of traffic. So that is some difference between this and the normal end.x behavior. And another response to Sasha's comments is that actually we think there's two sides of the endpoint. They don't need to, this link, this interface does not need to be layer 3 enabled, because they can, as long as they can have this agreed encapsulation, they can, you can build a transport channel, no matter it's OTN or maybe the MTN. It's just you can forward the packet to the other side, then it will be processed properly. So this, I think it is possible to avoid building a layer 3 adjacency between these two kind of nodes, because there's some challenge in some scenarios.
Hi, Lu Yan. Tom Hill from BT. I think I understand the draft and the presentation and the proposal, and I think as a requirement, a prerequisite for this to work, there has to be some form of layer 3 connectivity between your IP routers and your MTN routers or switches, however they're described, such that you can actually communicate across that boundary. Is that correct?
I think if we divide this behavior, it may have some requirements for the MTN nodes, yes. But since now the MTN routers and IP routers are in different, we list in the different areas or domains, so in the current SRv6 behaviors, it can not enable the end-to-end programming now. Yeah.
Right, okay. So, I mean, in most cases that I'm aware of, we don't tend to connect these things together on purpose, and such that they can't talk to one another, and they certainly can't tell each other what to do. So ultimately, I feel as if there is a very broad title for this draft when it's actually quite a limited set of circumstances whether it can actually work.
Since now some services, they require a very strict requirements, for example, in the latency or in the bandwidth. So if they require the low latency, we hope to choose better underlay passes for these services. For example, to choose a better optical connection or better MTN connections. This in the China Mobile, we have a long distance between, for example, two data centers. So it must to cross different domains. The IP routers is also under the IP networks. It has optical networks or another MTN networks. So we hope to choose a better path for the end-to-end.
I understand what you're attempting to do. Yes,
thank you.
What I'm trying to get at is that there is no trust between an optical network and an IP network. And this proposal, I think, implicitly requires trust between those two networks. And I don't think that exists in many situations, none that I'm aware of. So where we have ODUK or DWDM options here, I would hasten to add, I don't think the vast majority of those would work in this instance. So this is a question really about scope of the draft and whether or not
I understand.
something that doesn't exist in a lot of places.
But maybe we can use the programming on the super controller. The controller can see all the different domain networks and to give the program.
Well, yes, an out-of-band controller, that might be possible completely, but that wouldn't be a network programming job. That would be a PCE job or something similar. Anyway, thank you for the clarification.
Thank you.
Right.
Hi, I'm Zan from ITE. Quickly reply to Tim. Yes, the two domain network are all belong to the same operators. And the China Mobile has the clear requirement, and our ZTE, our company have implemented it. And the China Mobile has successful complete these functions. Maybe we can take it offline for details.
Right, yeah, I'll just clarify that
Yeah.
even if we own both of the networks, the optical and the IP, we still don't trust each other, which is usually done on purpose, right? But it's a zero trust architecture. You segregate your networks on purpose to make sure that they can't affect each other. So I feel as if that's a very common deployment,
Yeah,
certainly in my end of the world anyway. So thank you.
Yeah, okay.
Great, thank you. We are going to move on. Jeffrey is going to talk about the microtap segment. Bruno, we're still seeing the old slides. We're seeing the wrong slides, actually.
Yep. Okay. So I want to present some updates to this microtap segment draft on behalf of my co-authors. Next slide, please. A quick background refresh. The microtap's SID is to instruct the node to make a copy of a packet, send a copy to a particular destination, and then forward the original packet to its original destination. By strategically placing one or more microtap seeds within a seed list, we can do the traffic tapping at target points within the network without the need to configure or unconfigure firewalls on those tapping nodes to start or stop the tapping of this traffic. Here, we achieve the micro control. So that's why we use the microtap there. It does not mean, it's not related to the SRv6 microseed. Next. The example here is that if you look at the picture on the right side, the client A is sending a blue packet to the server B, goes through router A, B, and C. The router A inserts segment list where it has purple, green, and yellow seeds. That purple seed is the router B's node seed, and the green seed is a micro-tapping seed. So when the router B gets that packet, it will do the tapping. Next slide, please. So the changes in the latest revision are basically two major changes. One is that the optimization we introduced in the case of SRv6, and we also added support of tapping by a monitor node itself. Next slide, please. So for the SRv6 operation, we extend this GID and LID concept, GIB and LIB concepts that was introduced in the compressed seed specification. Now, the monitor node that is attached to the monitor, it will allocate the ID from the global ID block and advertise it. The semantics of that is basically macro tapping to the advertising monitor node. We refer to this ID as a tapping ID, and this tapping ID can be used as either a compressed seed or as a functional base of a full seed. Next slide. So the specific signaling operations, trying to explain it here in 2 slides. The monitor node, which in the previous picture where it's the router D that is attached to the monitor. It advertises end seed with the end.tap behavior using that locator block, locator node, functional bits, and argument bit structure, where we use the functional bits to encode the tapping ID that we talked about earlier. After it advertises that, it installs a corresponding IPv6 route so that when a tapping node sends a copy of the packet, and when that copy arrives on this monitor node, it will send that copy to the monitor. For example, router D that has the locator 00D0, it allocates a TID from the global ID block 1000 for the tapping purposes. So it will advertise that NSID using that structure and install the corresponding route LB:00D0:1000. And so that's when it gets the tapped packet, it will forward the packet to the monitor. That's the monitor node. And the tapping node, if a node is capable of doing tapping, it will set a new T flag bit in its locator TLB, indicating that it is capable of doing the tapping and for packets received with this particular locator. And also, for each locator, it advertises with that T flag, and for TID that is received from a monitor node, it installs a route to do the tapping. For example, node B, it has a locator 00B0, and it received tapping ID 1000 from the node monitor node D. So the node B will install LB:00B0:1000, install that route to do the tapping. Next slide, please. And when ingress router, ingress node receives the same advertisement, for example, the NSID from monitor node D with 00D0:1000 with the NTAP behavior, and B's locator LB:00B0 that has a T flag set, then the ingress node knows that B is capable of tapping. And if the ingress wants B to do the tapping, then it will use LB:00B0:1000 to instruct node B to do the tapping to node D. This works for both full seed and next C-seed flavor of the compressed seed. And that's because longest prefix match on the combined LB:00B0:1000 routes. In the case of the C-seed, the 00B0 and 1000, they are all compressed seeds. Next slide, please.
Jeffrey, we have 2.5 minutes, 3 slides, and 4 questions.
Yeah, okay, yeah. So another thing we added is the tapping by monitor node. So far, what we have talked about is that basically the tapping node and monitor nodes are different. There could be a case that the monitor nodes may be on the normal forwarding path, and you may need to do a tap to its own monitor. What we described earlier is not enough for this. For that, we introduce separate local ID block, TID, and for the local tapping purposes. I'm going to skip the details here. It's in the slides and in the draft. Next slide, please. So summary here, we extend compresses give leap concepts to the functional bit space of full seeds, and the monitor nodes advertise global tapping ID and advertise in the functional parts of the NTAP seed. It installs a local forwarding route to send tapped packets to its monitor. And the tapping node combines the received gifted with its own locator and install a local forwarding route to do the tapping. The ingress nodes does the similar things, but use that resulting either full seed or a series of compressed seed to instruct the tapping. And also we introduced this leap tapping ID so that the monitor can tell others that if you want me to do the tapping, you need to use this one. Next slide. So we continue to see.
I'm just going to, we have 11 seconds, Greg. Make it quick.
Okay. So this might be applied arbitrarily to random packets. So in your opinion, how that might impact ECMP that uses their header information to generate entropy?
ECMP. In the SRv6 case, ECMP hashing, and I think it's based on that flow label, right?
It's recommended. There is no requirements for that.
Okay. In the SRv6 case, I don't see how this will impact the hashing. In the MPLS case, indeed, if you're hashing based on the label stack, you may have an issue there. But as for SRv6, so far, I don't see an issue here, but we can follow up.
Well, I'm opposite. Let's discuss it in the list.
Yeah.
Thank you.
Thank you. Safar?
Yeah, so this is Farley. So basically, we did discuss some of these things during the ONM for SRv6 ONM. And one of the problems that Greg described is it applies that because sometimes you do the samples of these packets for tapping and all. And if you have a SID, it impact the load balancing or hashing to the packet. So your normal flow and tap flow are different forward. But why I'm mentioning that at the end we define an O flag for these purposes that they're exactly same is it does send a copy of the packet, and how that packet is processed further on is a local matter. How you get to the monitoring node is a local matter on that node. And one thing which is very clear in the RFC is that the configuration driven, the O-bit processing is configuration driven. So you can actually just configure on the node that you want to tap from. So I would like to see an analysis of why that was not used. And then there's another option of doing replication. We have defined replication segments. So if it's a matter of replicating, then that is another option. So I'd like to see that discussion.
Yeah.
Thanks, Safar. Sorry, we're going to move real quick because we are already over time.
Yep. Just a very quick comment. I think this is the document that could really use security consideration from a very, very start. This is going to come up. So rather than putting it at the end, let's analyze how it could be, what's the threat model for this. Another issue would be that lots of details we have currently set out of scope, and I think which are mainly the operational aspects, like how do I decide where to tap, what's the right place. And I was thinking from the PC point of view, there is a section, but it doesn't describe that what information does a controller take into the consideration. And my final comment is, which was something that like while I was coming, it hit me that maybe should we be using the word tap, especially because of the higher level policy that we have, IETF policy on wiretapping, and this, it has negative connotations. So we have to think about this as well, whether it's the right term or not. Thanks.
Thank you.
Thanks, Jeffrey. We're going to move to the next presentation, Shikian Li. your remote. Leave. And you have 10 minutes, including the question.
Okay. Hello, everyone. I'm Zixiang Li from China Mobile. I will present the SRv6 span draft on behalf of my co-authors. Next slide, please. First, some background and modification. Today, the scale of networks is becoming larger. Network traffic is becoming more complex, and the requirements for network operation and maintenance are becoming more and more sophisticated. SPAN technology is one of the essential tools for large-scale data centers and distributed AI training scenarios. SPAN or RSPAN is not sufficient. To remove the limitation that the mirror server needs to be directly connected on the physical or layer 2 link during networking, overlay tunnel like ERSPAN is used. ERSPAN uses GRE for tunneling encapsulation, but the most popular tunneling protocol for data center now is VXLAN. SRv6 is capable of connecting overlay and underlay networks and widespreadly deployed. So it's time to do something to keep things simple in pure SRv6 network. What's more, with SRv6 SRH seed list, the imagination of SRv6 span is just beginning. Next slide, please. There is some principles and considerations to compatible as much as possible with a large number of analysis software that supports ERSPAN, and to take full advantage of SRv6 capability, we propose an SRv6 span solution so as to simplify the network architecture where the span or mirroring technology is used and deployed, and be compatible with the packet formats of conventional mirrors like ERSPAN, and enhance the mirroring technology to meet new requirements. Next slide, please. There is some function process of SRv6 span. SRv6 span is not only compatible with a device that supports only IPv6 capability, but also matched with a network device with SRv6 SRH processing capability. There is 6 steps. First, we should enable device SRv6 span function, and the device will capture forward information and mirror original packet. Then the packet encapsulation of SRv6 span is applied. SRv6 span packets transport through SRv6 TE or B paths. Then the remote mirror server decapsulates the SRv6 span packet. Last, the mirror server analysis and process the mirror packet and its metadata. Next slide, please. Okay, this slide is a detailed illustration of the functional process. And the ERSPAN encapsulation header can be located directly after an IPv6 header or after SRv6 SRH header. And the remote server can be located anywhere if the IP packet can be reachable. The blue line is the original packet forwarding path, and the blue line is SRv6 span packet forwarding path. Next slide, please. The following are basic capabilities that need to be supported in the current version of SRv6 span. For example, regard to the enable SRv6 span capability, we can do it port-based or flow-based. And the capture switch forwarding information can include timestamp, hardware ID, SGT, COS, etc., and the original packet. SRv6 span packet encapsulation can be the SRH or SRv6 span with 128-bit SRv6 seed. Next slide, please. SRv6 span will be further developed, and the enhancement points will be detailed in subsequent documents. For example, we can base event or ECN or latency and jitter to enable the SIV6 span. And the capture forwarding information can flexing or can be in the flex mode, and the original packet can be compressed to avoid the pass MQ check fail, and the packet encapsulation can support GSRv6 seed and the retransmission of SRv6 span packet for lossy network. Next slide, please. Thanks for your time. Comments are welcome to improve the document and welcome to join our work. Thanks.
Any comments? Okay, then we're going to move on. Please make any comments on the list, of course, to the format 6 segments for IPv4 service. Dong.
Okay. Good day, everybody. I'm Guo Zhendong from China Telecom. The draft name is Format 6 segments for IPv4 service delivery over IPv6 only underlay networks. Next. Before I dive into the updates, let me briefly outline the draft background. In the draft of a framework of multi-domain IPv6 only underlay network and IPv4 as a service, it proposed a framework for deploying IPv6 only as the underlying multi-domain networks. In this framework, each PE will be identified by at least one IPv6 mapping prefix. It will also have one or more associated with IPv4 address blocks, which are extracted from local IPv4 routing table or address pool. A specific data structure is identified as address mapping rules to express the mapping relationship between IPv4 address blocks and the IPv6 mapping prefix of the remote PE. The mapping-based conversion can also work in SRv6 networks. Therefore, for map6 segment is defined for segment routing. They run in PE nodes and provide support for implementing IPv4 and IPv6 conversion function based on mapping rules. Next, please. Based on the suggestions and comments of the last presentation, we made great adjustment to the draft. Compared with the last version, the following updates have been made. We renamed the M46S seed and M46D seed by map6 segments, refined the architecture and relevant field of the map6 seed, added relevant SR6 service TOV extension, refined details behavior of map6 segment on ingress PE and egress PE, refined the inner consideration and modified some typos else. Next, please. In the first place, the locator field is used to identify the node that is instantiated to the map6 seed. The function field identifies the behavior bound to the map6 seed. It takes 32 bits of argument because the ARG field contains the behavior identity of vendor statements encapsulation or translation is performed at that point, and the IPv4 address associated with the PE node. The value of L plus F should be less than or equal to 96, since 32 bits are required for IPv4 address. Next, please.
Sorry, there's a question. Ketan, do you want to ask now or later? Okay, later.
Okay.
Go ahead, keep going. You have 6 minutes left.
Yeah. Secondly, in section 3 of the draft, defines a new BGP prefix seed attribute extension TOV in the SR6 service TOVs to implement seed signaling for the 4map6 service of the SR6 service. In the field of TOV type, it is set 8 for SR6 4map6 service TOV. Next, please. We also added the part of SRv6 service sub-TOV. The SRv6 seed information of ForMap6 service is filled in the SRv6 service sub-TOV value field. Next, please. In the section 4, we have made a large update of the content for particular data stream. One node is the ingress PE, denoted by PE1, and the other is the egress PE, denoted by PE2. Each PE maintains a mapping rule database. The table entries in the MD database consist of IPv4 address prefix, IPv6 mapping prefix, and the encapsulation or translation processing way of IPv4 packets. Before transmitting the IPv4 packet from PE1 to PE2, and the address mapping rule corresponding to its IPv4 destination address needs to be transferred from PE2 to PE1. Therefore, PE2 supports a 4map6 service based on SRv6. Publish the 4map6 seed corresponding to the IPv4 destination address in the BGP prefix set attribute, so as to realize the PE2 node located at the edge of the network to other nodes and synchronize the address mapping rule database on each BE device. PE2 announces its capability to other nodes in the format of the 4map6 seed of the SRv6 domain in the control plane. When the PE2 receives the 4map6 seed announced by PE2, it extracted the relevant information and stores it in the local mapping rule database. Next slide, please. We also updated the content of INA consideration. The endpoint behavior is updated to end.4map6. Next slide, please. Okay, next steps, we encourage more discussions on mailing lists. Comments and suggestions are welcome. We will prepare new version for IETF 121. That's all. Thank you.
We have a question here. Ketan, go ahead.
Ketan Talaulikar, Cisco. So this work stems from a V6 Ops document that you reference, I think, on the second slide. I noticed that V6 Ops document doesn't talk about segment routing or SRv6 at all. And there is proposal in IDR to do this. There is a extension in IDR adopted working group, which is also not using SRv6. So I'm looking for, what's the difference between that solution and what's being presented here, and yeah, so something like that clarification.
Could you please get sending out to the list?
I'll send it on the list as well. Yes.
Yeah, with the IDR draft, so that we all know what we're talking about.
Yes, I'll provide all the references. Point.
Thank you, Tom.
Thank you.
Okay, I'll just talk like this. Tom Hill from BT. I was kind of listening along to the presentation and trying to read the draft at the same time, and I think what it's actually missing in particular here is a cast iron description of why. I think I fundamentally understand what it is that you're trying to describe and design here, but I don't understand what the application is. I don't understand why we need this, because we already have capabilities for IPv6 only SR MPLS domains, IPv6 only SRv6 domains, and we can carry IPv4 traffic across those.
Yeah.
It's a very I think it's a very limited application here for this new work, and the best thing that you could probably do is probably add a section that describes the intended deployment.
For the case of IPv6 only deployment, since the IPv6 users needs to access IPv4 internet service, in this case, users can have only IPv6 address. So the approach needs to consider translations as well as encapsulations.
So you're confusing two streams there. So either you're talking about v4 only transport routers that underlay, or you're talking about providing IPv6 connectivity to services that can only support IPv4 or IPv4 only destinations. We have a bunch of protocols for this already in MAP, NAT64, 464X, a bunch of whole things that we use and do already. If there's no example that you want to put into the document, then perhaps a comparison with other technologies that already exist.
Yeah, so this is also similar to what Ken was asking of the comparison with other technologies and other work. So let's take, because this is a longer discussion, this to the list.
Well, thank you.
Thank you, Tom.
Okay, thank you.
Thank you for the presentation. We're going to move on to the encapsulation of BFD and SR6 policy. Xiaoming, you have 10 minutes.
Hello, everyone. I'm Xiaoming from ZTE. This presentation is on encapsulation of BFD for SRv6 policy. This draft was presented at IETF 118. So this time, I just want to present the main updates since that's IETF. Next slide, please. This is a recap of this draft. This document describes the encapsulation of BFD for SRv6 policy. BFD packets can be encapsulated in two modes, insert mode and encaps mode. The BFD must be phase sharing with state traffic. For insert mode, BFD packet is encapsulated within the UDP header. And the outer header is a single IPv6 header. For the encaps mode, BFD packet is also encapsulated within the UDP header, and the outer header is a double IPv6 header. And next slide, please.
Greg, do you want to ask a question now or wait?
I can ask after this. There is enough time.
Okay, so let me go on. This draft was presented at IETF 118, as I said, and Greg made good comments on this draft. It's not IETF. So the 0.3 version was posted to address Greg's comments. And they also want to express their sincere thanks to Greg. Thank you. Next slide. So this is the first main update since IETF 118. We have a new text in introduction, as specified in draft IETF Spring BFD. The basic element monitored by the BFD is a segment list. That is a constituent of the candidate path of the particular SR policy. And also, we copied the text in the Spring BFD draft here. And you can see it's aligned now. So if the Spring BFD working group document is going to be changed as per our review and comments, our draft can follow that change. And I think that's not a big problem. So next slide, please. This is the second main update since IETF 118. So there was concern that BFD echo packet should not be included in this draft. So among discussion within the authors, we decided to remove the BFD echo packet encapsulation. So currently, the latest draft only includes the BFD encapsulation, BFD control packet. So furthermore, we also do a change to the name of the mode. So in originally the name transport mode is renamed to insert mode, and the tunnel mode is renamed to in-caps mode. The new names are from the SRv6 behaviors, h.insert and h.in-caps. So we think the new names seems more clearer and better. Next slide, please. This is the third main update. In section 3, we use normative language recommended to substitute the lowercase main. Because according to the current implementations, for BFD control packet, it's recommended to use the header-end IPv6 address of the SRv6 policy as the source address, and also recommended to use the endpoint address of the SRv6 policy to be the final destination address. So we make this change. Next slide, please. Next steps, we ask for more review comments. We will revise this draft. And then if there's no more concern, we ask for working group adoption. That's all.
Great, go ahead.
Okay, yes, thank you. So I have probably two questions. First, it's observation. In introduction, it stated that demand mode is out of scope, but it appears that this proposal is covering BFD over multi-point networks, 8562, which uses demand mode. So I think that you need to revisit it and clarify the scope of the document, so whether it's applicable to multi-point network or it covers demand mode.
Okay.
Second is about in caps. So in the figure, you demonstrate second IPv6 header. So, and there is no discussion about how the destination address in this inner header is selected. So I think that something needs to be clarified, the selection of destination address in the inner header. Second, the question is, so do you see that it can be only IPv6 in caps mode inner header, or it could be IPv4 inner header? So that's something that might be clarified as well.
Yeah.
And after all, actually, I think that motivation for using in caps mode compared to the insert mode. So what the benefit also will be helpful if you clarify in the document. Thank you.
Thank you very much.
Thanks, Greg. So we have 1 minute.
I have 1 minute? Okay.
Well, you have one, he has one to answer.
Okay. So in IDR, we're going through a BFD strict mode. Is this adhering to BFD strict mode for, or working on that concept? Let me start with that high level.
So you mean how to use BFD strict mode?
Yes, there's BGP finite state machines over links for BFD strict mode. And then what you're doing is you're putting on top of that an SR tunnel and you're running an encaps on top of that. And I'm just wondering how it affects the state machine in the BFD strict, or if it doesn't apply, or, you know, we can take all of this on offline, but there's some details, and I'm the shepherd for the BFD strict. So I'm seeking information and help.
Sue, as an author of the VSD strict mode, I
Yes.
think I can tell you that that is based on the VFD peers for the protocol, so it's control plane, where this is a data plane verification of the paths that are specified that just happen to be provisioned using BFD, not BFD, BGP, excuse me. So the only tie here is one is that those paths are advertised in BGP, but this is for the as you know, the BGP state
Right,
machine. So
right.
they're sort of related, but they're not
I'd like to peel it down, but thank you. That's a good introduction, and I'll dig in a bit further. Thank you.
Thank you. Everyone, we're going to move forward to the next presentation. Thank you.
Thank you.
Problem statement for aggregate header limit. Yao Liu, you have exactly 9 minutes. We want to get to all the presentations. Thank you.
Okay. Hi, I'm Yao Liu from ZT, and this draft is about the problem statement with aggregate header limit. Next slide, please. So aggregate header limit, as introduced in IFC 8883, is a total header size that a router is able to process due to its processing limit. For devices with passing buffer, it's related with the device buffer size. So packet may be dropped or sent to slow pass if the limit is exceeded. The starting point is that the total packet header chain size is increasing, especially in SRv6. Here we list some adopted works that would increase the total header size. So whether they are encoded as seedless, SH-TRV, whole by whole TRV, or DOH TRV, and they can be used together. So, and another point is that there are still some potential extension requirements to make the header size even bigger. The next slide, please. So there are some different types of nodes involved in SRv6 networks. Normally, the intermediate SR nodes, which processes a local segment in the DA, has the biggest burden on processing packet headers. So in the example shown here, if the intermediate SR node is expected to process the SIH-TRV at a fast pass, it should be able to read all this header into its buffer. Next slide, please. So the potential problems. First is the combinations of different functions would make the total header size even bigger. And the operator's network usually consists of different versions of devices from multiple vendors, which often have different processing limits and different behaviors after limit exceeding. So which makes it difficult to manage. And the thirdly is parts calculation without awareness of aggregate header limits of the nodes, and the prediction on which feature would be enabled may result in a passing through nodes with lower aggregate header limits, than required. And the packet encapsulation by function enablement may lead to packets being encapsulated with larger header size than the downstream node able to process. So the observation is that an aggregate header limits of the node or the path needs to be availed. Next slide, please. So Here are some use cases if you are aware of the average header limit. So when the centralized computer computes an SR parse from S to D as required, and it's aware of the aggregate header limits of the nodes in the path, and it knows that the whole IOM and network slicing would be enabled on this path. So the output would be a set list between S to D and leaving out the space for a whole by whole header with options for IOM and NRPID. And besides path calculation for the headed or the intermediate nodes, when the node needs to increase the size of the packet header along the existing SR parse due to certain function enablement, but the aggregate header limit of the downstream nodes along the path are not sufficient to process headers. So if the node is aware of this information, then the node may choose not to enable the related function and log an error. Next slide, please. So here are some considerations on how to obtain aggregate header limit. The existing mechanism introduced in IFC 8883 is when node discards a packet due to aggregate header limit exceeding, it would send an ICMP v6 destination unreachable error with code for headers too long. So this may not work well when there are a large number of parts, because the burden of sending and receiving messages increases. If you want to leverage this mechanism for aggregate header limit detection. And for dynamic paths, the segment lists may change over time, which makes it more difficult to get the aggregate header limit in advance. And the potential options might be signaling, so the aggregate header limits of all the nodes in the domain can be obtained easily, regardless of the amount or the type of path. And for the controller, you can use some south-north mechanisms. And next. I think that's all. And welcome feedback and comments.
Any comments in the room? Eric?
Eric Lang, Cisco. It seems like an interesting problem to be solved, indeed. Just a small comment on slide 2. You indicate RSC 8883, but it's just an ICMP. I'd suggest to use a refer 9098, which is about the optional consideration of using extension headers. That's all. Thank you. Interesting work.
Okay. Okay. Thank you. Suggestion.
Jeff, go ahead. You're not in the queue, but I see you're trying, so.
It's still coming up. So I assume you're familiar with the MSD framework that has been published. It has extensions for SPFSS and BGPLS. It's standardized. There's young models that also define some basic stuff for a service 6. I mean, you're trying to do exactly the same thing, right? Why?
Yeah, kind of the same thing, but I've read the MSD about SRv6, but all these SRv6 MSD are about the limits of the segment lists in the SRH, but about all the aggregate headers, so there are not such mechanisms.
So what it requires is new MSD type that signals additional metadata.
That seems like a good discussion for the list. Thank you, Jeff. Sasha, 57 seconds.
Sasha Weinstein, actually, I wanted to say more or less what Jeff has said. There is a similar problem with MPLS and maximal stack depths and maximal that can be imposed by a device and maximal readable stack depths. And there are well-recognized mechanisms for
making the controllers aware of both these limitations. So I think that more or less the same should be done in this case.
Thank you. We don't have anyone else in the queue, so we're going to move to the last presentation. Balázs.
Hi, my name is Balázs Varga, and in this slide kit, I would like to show a new .NET data plane, which is based on SRv6 technology. And by the way, this is two drafts. We have a draft for the .NET workgroup, which was already discussed during the week. And this is describing in detail the .NET specific packet processing and how this concept works. In order to have to use SRv6 for the .NET as a data plane, we have defined a .NET specific seed, and this is for what we have created a document for the Spring workgroup, which is describing the seed and the related SRv6 behaviors. Next slide, please. In the deterministic networking architecture, it is describing a network domain which is capable to provide extremely low data loss rates and bandwidth latency within a network domain. And there were various techniques defined in the network architecture in order to ensure these characteristics. There are two sublayers defined in .NET. One is the service sublayer, and it is responsible for the service protection. In order to achieve service protection, it is using a per packet replication and elimination functionality. And the other sublayer is the forwarding sublayer, where this replication and elimination functionality is usually combined with explicit rules. For .NET, two data planes were defined in the .NET workgroup, an IP and an MPLS data plane. In order to achieve this pre-op functionality, you have to have sequence number information traveling with the packets. And this is something that was challenging to define for a universal IP data plane. So in the first RFC defining the .NET IP data plane, it had limitation regarding supporting this .NET service sublayer. The workaround was provided in the .NET workgroup by combining the .NET pseudo-wire technology and MPLS over UDP technologies in order to define an IP data plane which is capable to provide this service protection functionality. Next slide, please. However, when we look to the .NET toolset, there are three major groups: the resource allocation, the service protection, and the explicit rules. And in this presentation, we will speak about the later two, service protection and explicit rules, because they are usually combined together. And if we would like to have a native IPv6 data plane, then the task that we have to solve is to add the sequence number information to the IPv6 header. And the option we will present in this slide and described also in the drafts, it is to reuse the existing IPv6 header fields. Next slide, please. This slide is showing the three major building blocks in order to create this .NET SRv6 solution. The first was that we have defined a .NET specific seed format, which was capable to contain the sequence number information. The second, that we have also described how to map the two arguments, which are two parameters which are needed for the pre-op functionality, the flow ID and the sequence number in the argument part of the .NET specific seed. And the third building block is the description of the SRv6 behaviors regarding this .NET specific seed. And here, one new endpoint behavior were defined, and four segment routing policy head and behaviors were defined. Next slide, please. just in order to show how many bits you need for these parameters to encode, this slide is just summarizing that. So we need two parameters. One is the flow ID. This is saying your packet belongs to which .NET flow. And based on that, you will be able to select which pre-auth instance you would like to use when you are forwarding the packet. In case of the MPLS data plane, we are using 20 bits of flow ID. So it would be great to use also the same size for the IPv6 data plane. Regarding the sequence number, various size were defined. So we need maximum 28 bits for the sequence number. So in total, you need 48 bits in order to encode these parameters in the argument fields. And if we look to the usual recommendation and widely used allocation of the seed bits, then you are usually using 64 bits for the locator, 16 bits for the functions, and you have exactly 48 bits for the arguments. Next slide, please.
Well, as we have about 4 minutes left.
Sure, I have just two more slides. So this slide is just showing how this .NET specific seed looks like. Here is one thing that I would like to highlight is that if your function is pointing to a pre-auth functionality on a .NET Relay node, then if your argument is 0, that is also a meaningful value for .NET nodes. Because we are using a circular sequence number space, and 0 is a valid number in that circular sequence number space. And of course, your flow ID can be also 0 if you are allocating that in that way. And the next slide is my last slide, and it is just providing an important aspect, which was also discussed on the mailing list, where we have received some comments to this draft, that the .NET specific seed is always the last segment in a segment routing policy. And in the draft, we have described in detail the endpoint behavior, which is practically a decapsulation behavior. And it is also describing how to forward to the .NET pre-auth functionality the values in the argument fields. And for the policy head-end behaviors, depending whether your payload is an IP packet or a layer 2 frame, for various head-end behaviors were defined. So that's it about these two drafts. It was already discussed in the .NET work group, and we have also received feedback on the Spring mail list regarding that. So we are seeking for further comments, and we are happy to discuss those aspects. And this is something we intend to build in the next version of the draft. And Sasha, please.
Hi, Sasha Weinstein. I would like to understand how this proposal is combined with what is normally done for SRv6-based BGP-based services. And the BGP-based services, the service instance is identified with an SID, which is SRv6 SID that is advertised in the normal way from egress to ingress in BGP. If you want for this specific service, being say point-to-point Ethernet line, virtual Ethernet line service, you want to apply pre-auth. How exactly would you combine this mechanism with the existing mechanism? Would you, because you have here an individual
SID for all individual PIRA EOF function for the entire node, effectively, which uses flow ID and sequence number. I'm not. I think this requires clarification because eventually you want most probably to use a .NET on services and not just in the air.
Yeah, I think that's a very interesting topic to discuss. Let's do it on the mailing list. Maybe just one immediate reply to that we have a .NET controller framework document as well, which is describing how to place these functionalities in the network and what signaling you may need between the .NET relay nodes. But let's discuss it on the mailing list in detail.
Sure.
I think that's a very relevant question. Thank you for the comment.
Sure. Thank you.
Thank you, Balázs, and thank you, everyone, for being here. It's time for a break. There's only one very exciting session after this, the ADR session, of course. We'll see everyone in Dublin. Please read your email and reply to the charter, comment on all the drafts that were presented here. Thank you so much.